Good morning, viewers. This is Kasturi Day. Today, I am going to start with the modern periodic table of your this chapter, which I was discussing. That is the periodic table. Before this video, I discussed about Mendeleev's periodic table and the primitive periodic tables, which were first uh, uh, which was first discovered. The table before formation of this table, the scientists who started to form this table, we discussed these tables also, their contributions also. So today I'm going to start with modern periodic table. Okay, so to start with this, I will first wish you a very happy Children's Day and uh, and a very happy good morning to all of you. And so, if you have not subscribed yet, please to subscribe my channel and please ring the notification bell because that will notify you as soon as the new video is uploaded. And if you are liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to meditate before you start your day. Okay, so for meditation, for just 1 minute, let us concentrate on a point of light. Think that light is falling on you, that point of light is falling on you, and your whole body is being lighted up. You're getting energy from that light, from that point source. You're feeling happy, enthusiastic, interested in whatever you are doing, what job you are doing, maybe may it be studies or any other job. Okay. And you're liking your work, and at the end of everything, you are becoming successful with the blessings of God. Okay. And last but not the least, to thanking Him for everything. And this is the end of the meditation. Let's not with it. Moving to the table. Okay. So according to modern periodic law, we know that the physical and the chemical properties of the elements are the periodic functions of their atomic numbers. Okay. So atomic numbers, we know that the modern periodic law is dependent on atomic numbers. Okay. Now the physical and chemical properties of the elements, atomic numbers of the elements. Okay. So the atomic numbers of the elements also determines the physical and the chemical properties of the elements. And they are the periodic functions of these atomic numbers. Okay. And therefore, the scientists arrange these elements in their increasing order of their atomic numbers from left to right across each row. So the elements having an equal number of valence electrons have similar properties, and so they repeat after regular intervals or periods. Okay, so when one goes from left to right in the periodic table, we see that the atomic number increases. Okay, and and what happens when the elements have the equal number of valence electrons same, but their atomic number may increase. Okay, like if the valence electrons are say 3, so throughout the period, throughout the row, the valence electrons will be 3. Okay, valence electrons, that is outermost electronic configuration, that will be 3. Okay, so the total valence electrons will be 3, equal number of valence electrons. The elements which are having this type of valence electrons, equal number, they will have similar properties. Okay, and as the number, and so this repeat at after regular intervals or periods. This is repeated at regular intervals or periods. also as the number of valence electrons of the elements show periodicity, that is regular repetition is found of these valence electrons. Okay. The chemical properties show corresponding periodicity. Okay. So what happens? We see that the valence electrons are similar or equal rather at regular intervals. This happens at regular intervals. And therefore, what happens? The properties, the chemical properties, that also repeat like this, maintaining their periodicity. That is, at regular intervals, the chemical properties also becomes the same. Okay, similar. For example, the first group of elements, that is lithium, sodium, potassium, rubidium, cesium, and francium, their atomic numbers are 3, 11, 19, 37, 55, and 87. Okay. So what do we see throughout the row? Okay. We see they are soft metal. What will be their characteristics? They all are soft metals. They have only one valency and so form unipositive ions. That is, their valence electron is only one. Okay, so they form unipositive ions. They are good reducing agents. They are very reactive. So they are found mainly in the combined state. They do not exist freely. They cannot exist freely as they're very reactive. So they combine with other elements to form a compound. Okay, they always are found in the combined state. Mainly they are found. Then they impart color to the flame when they are burned. Okay, then they form hydrides with hydrogen. They form basic oxides with oxygen. They react with the metal oxides to form hydroxides and hydrogen. Okay, they react with the metal oxides to form hydroxides and hydrogen. So what happens? These all characteristics are found in all the first group elements. Okay, that is lithium, sodium, potassium, rubidium, cesium, and francium. And their atomic numbers C, 3, 11, 19, 57, 55, and 87 all have their valence electron as 1. That's why they are unipositive ions and their valency is 1. Okay. So this we can see their characters are almost similar. Chemical characteristics are similar. Okay. This is due to their valence electrons, their atomic numbers. As their atomic numbers are similar. Okay, therefore, that increases as we go down from top to bottom, and we will see that their chemical properties also are similar. Okay, so this is according to modern periodic table. They are arranged in one row, okay, rather in one column. Now, all these elements have 1 electrons each in their outermost shell, and so they have similar properties, as it is noticed that elements having similar electronic configurations have similar properties. Therefore, the cause of periodicity is the same number of electrons in the outermost shell. That is, the recurrence of the similar chemical electronic configuration. Okay. Therefore, what is the cause of the periodicity? Cause of the periodicity is the same number of electrons in their outermost shell. Okay. So why there is periodicity? What is the reason behind periodicity? It is the same number of electrons in their outermost shell of the element. And that is that there is a recurrence of the similar electronic configuration. Okay. So what happens? The properties, what is periodicity? What is periodic properties? Okay. So what is that? The properties that reappear at regular intervals or in which there is gradual variation. Okay. The properties which reappear at regular intervals. Okay. At regular intervals, if they are repeating or if there is gradual variation that is, they are increasing or decreasing at regular intervals. like slight increasing, they are moving from one left to right, or they are decreasing when it is moving from left to right, like this. If they are, that is in regular intervals it is happening, or if they are similar when it is going from top to bottom, they are similar in nature, or they are happening at regular intervals. This type of properties are known as periodic properties. Clear? And the phenomena is known, this phenomena, this repetition of regular of properties at regular intervals, or gradual variations at regular intervals, though these type of phenomena is known as what? Periodicity of elements. Am I clear now? Okay. Any doubts, please do write in the comment box, okay? Or you can also write at my email ID, that is Kasturi74, Kasturi, Kasturi74@gmail.com. Clear? Next, we are moving on to the causes of the periodicity in the modern periodic table, okay? Now, the cause of periodicity is the properties, in properties is the repetition of similar outer electronic configuration at certain regular intervals, as I told you earlier. So the cause of periodicity is mainly what? It's a repetition of similar outer electronic configuration after certain regular intervals. For example, all the elements of group 1, all the elements of group 1, they are known as alkali metals, okay? They have a similar outer electronic configuration of NS1, okay? That is where N means what? It's the principal quantum number of the outermost shell, okay? It's the number of the outermost shell, that is N, okay? So NS1, that is electronic configuration is NS1, that is its valency is 1, valence electron is 1, okay? So all the elements of group 1, they have valency as 1, or unipositive ions they have, or they have only 1 valence electron, okay? In the same way, the elements of group 17 have a similar outer electronic configuration of NH2 and NP5. Hence, they have similar properties to one another, and they are called halogens. Okay, group 17, that is the group of halogens having the electronic configuration of NH2, NP5. Okay, that is, they have how many electrons? 7 electrons in their outermost shell. Okay, they have, all of them have their similar properties. Okay, similarly, group number 18, which is a noble gas group. Okay, that is, we have the inert gases or noble gases there. Okay, so similarly, the group number 18, they have an outer electronic configuration of NH2, NP6. That is, they have valence electron as 8. That is, their valence electrons are filled up. Okay, that valence shell is filled up. Okay, that is total filled up valence shell with 8 number of electrons in the outermost shell, fully filled orbital. Okay, that's why they are very stable. They do not react. They are inert. Okay, they are not non-reactive elements, and so they are known as inert gases. But helium is the only inert gas which has an outer electronic configuration of NS2, but it falls in the same group because it also has the fully filled outer orbit. Outermost shell, outermost orbit is fully filled. That is 2 electrons in the outermost shell. Okay, it does not have any more electrons. So that's why its outer orbit is filled with 2 electrons. Other inert gases, other elements of the inert gases, they all have their 8 electrons in their outermost shell. Okay. Likewise, the elements in a group have similar properties to those of all the other members of the same group. This is because Elements in a group, any group of the same group, they will have the similar properties because they have a similar electronic configuration of their outermost shell. Okay, hence even the number of shell increases down the group, elements of the same group, they will have the same electronic configuration and similar properties. Clear? Now, what are the salient features of this modern periodic table? Okay, important features. Salient means important features. So what are those? The modern or the long form of periodic table. The modern periodic table is also known as long form of the periodic table. Long form periodic table. It is based on what? It is based on modern periodic law. Okay. The table is the arrangement of the elements. So what is the table? What is the modern periodic table? It's the arrangement of elements in increasing order of their atomic numbers. The modern periodic table is the present form of the periodic table which we are having now, and it consists of 18 vertical columns which are known as groups and 7 horizontal rows which are known as periods. Okay, 7 horizontal rows, those are known as periods, and 18 columns, vertical columns known as groups. Now groups, we are coming to groups first, groups in the modern periodic table. We know that it has 18 vertical columns known as groups. The first main group will be 1 to 7. Okay, while 0 group is single. That is, there are 8 groups. Clear? So 1 to 7 are subdivided into subgroups. Okay, while 0 group, another group is there, that is the 8 group, that is the 0 group, that is single. That is not subdivided into subgroups. They may be making a total 18 groups. That is 1 to 7. They will have 2 groups each. Okay. And the last group is similar, like that. So, not 2 groups. It will have subgroups. Okay. Many groups are there in between 1 to 7. That is, all the 7 groups are subdivided into subgroups. And the last group, that is the 0 group, which is the inert gas group, that is simple. Okay. Now, the elements of subgroup A, that is 1A, 2A, 3A, 4A, 5A, 6A, and 7A. These are groups of, say, 1, 2, 13, 14, 15, 16, and 17. Okay. So 1A will be of one group, group number 1. Okay. 2A will be of group number 2. 3A will be 13. 4A will be 14. 5A will be 15. 6A will be 16. And 7A will be 17. As are called the main group elements or representative elements, or you can say normal elements. So subgroup A, that is known as the main group elements or the representative elements or normal elements, having their outermost shell incomplete. Having their outermost shell incomplete. Okay. The elements of the group 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, they are transition elements. Those groups are transition elements. Those group elements are transition elements, and they have 2 outermost shell incomplete. Representative cells have their outermost shell incomplete. In case of transition elements, they have 2 outermost shell incomplete. The 0 group or group number 18, which is known as noble gases or inert gases, they have stable electronic configurations and they hardly react with any other elements. Helium is an exceptional. I told you helium has 2 electrons in the outermost shell. Okay. Move on to the next page. We now come to the periods. In my last page, it was groups. Now we come to periods. The number of cells, we know there are 7 periods. The number of shells present in an atom depends on its period. How many shells it will have, that depends on its period. Okay. There are 7 horizontal rows. We know these are known as periods in the periodic table. Now, 1, 2, 3, 4, 5, 6, 7 from top to bottom. The first period, that is atomic number 1 and 2, consists of 2 elements. Okay. That is helium and hydrogen. They will have 2 elements in their outer. They consist of 2 elements. Okay. I mean, atomic numbers as 1 and 2. Hydrogen has atomic number of 1. Helium, atomic number 2. Okay. Then second period. Atomic numbers from 3 to 10. And the third period, atomic numbers from 11 to 18. They consist of 8 elements each. So first period, there are 2 elements. Second period, they have 8 elements. Third period also they have 8 elements. But second period, their atomic number ranges from 3 to 10. That is all the elements, 8 elements, they will have either atomic number 3 or 4 or 5 or 6, like that. 3 to 10. Third period have the atomic numbers of 11 to 18. Fourth period will have 18 elements and the atomic numbers ranges from 19 to 36. Fifth period, atomic number will be 37 to 54. 18 elements each. Sixth period, atomic numbers 55 to 86 consist of 32 elements. Okay. Sixth period, they have 32 elements and their atomic number ranges from 55 to 86, which is the longest period. And the seventh period of the periodic table has 4 new elements there are. What are those? Nihonium, that is atomic number 113. Moscovium, 115. Tennessine, that is 117. Organism, 118, which completes the 7th period with 32 elements. 6th period also has 32 elements. 7th period also has 32 elements. But in the 7th period, there are 4 new elements which have been added. This is also a longest period like that of the 6th period. Okay. Now, this period, it consists of 14 elements in the 11B group of the 6th period, which are known as lanthanides and actinides. 6th period has lanthanides and group 3B, 7th period is actinides. Okay, they are called actinides. So what is lanthanides or actinides? I'll tell you. So their lanthanides, their atomic number ranges from 57 to 71. Okay, they will start, their name starts with LA to LU, like that. And they begin with the atomic number 57. LA will start with 57. And there are 14 elements present in lanthanides group. Okay. And third B, 7th period, they are called actinides, where atomic number ranges from 89 to 103. And actinides AC starts with 89 atomic number, and their name, the last name which is added in this actinides group, that is LR. Okay. Now, lanthanides are rare earth metals and okay, rare earth elements, and actinides are radioactive elements. Okay, so lanthanides are rare earth elements and actinides are radioactive elements. They have similar properties as they are in the same group. They are in the same group, that is 3B, so their properties will be similar, both lanthanides and actinides, but they are shown at the bottom of the period. if you see the period, if you see the table, periodic table, you will find these lanthanides and actinides, they are present below the actual main periodic table. Why? Because they are large in number, and if they are shown in the main body, that will distort the shape of the table. That is why they are kept below the main periodic table. Now, elements with electrons increasing arithmetically in their outermost shell, that is one by one till an octet is attained, are placed in the same period. Okay, elements with electrons which are increasing arithmetically in their outermost shell. One by one, they are increasing to form till an octet is attained. They are placed in the same period. The last element of this period has 8 electrons, except the first period where helium has 2 electrons. Okay? Helium has 2 electrons in the outermost shell. So the first will have only 2 electrons. The other elements which will be down the period from 2nd to 7th, they will have 8 electrons on their outermost shell as the last element, having in the last element. Okay. Now, what are the classifications of the modern periodic electronic configuration table? Okay, modern periodic table. It can be done in the 4 ways on the basis of electronic configuration. It has been done as in the 4 ways. That is, representative elements, transition elements, inner transition, and noble gas elements. Okay. So representative elements are S block and P block elements, not S block, but S block. S block and P block elements which come under this category, that is under the representative elements category. Elements in group 1 and 2 are known as S block elements with outermost electronic configuration as 1s2 and 2s2. Whereas group 13 to 17 are P block elements, outermost electronic configuration are NS2, NP1 and NS2, NP5. NS2, NP1 to NS2, NP5, they are present in they are P block elements, as their P block will be filled. Okay, half filled elements. That is, P block is incomplete. So that will be NS2, NP1, NS2, NP5. Till this one, they will be filled. The elements will be found. Their electronic configurations will be like this. Groups 13 to 17. Group 1 and 2 are the S block elements because the S block will have 1s2 or 2s2 outermost electronic configuration. Okay. Now, transition elements are from group 3 to 12. Okay, where their electronic configuration, outermost electronic shell configuration will be N-1, D1 minus 10, NS1 to 2 are referred to as transition elements. These elements are D block elements. Their D block is not filled properly. They are incomplete. D block element, D block is not filled. SPDF. So these are the shells. Okay. So first S block will be group 1. P block is group 2. Then group 3 to 12 will be D block elements, where D blocks are not filled. Okay. Not filled. No, it's not. It's wrong. It's incomplete. D block is incomplete. Okay. Now, inner transition metal elements are, excuse me, lanthanides and actinide series, which fall at the bottom of the periodic table. In these elements, the 4f and 5f orbitals are partially filled. Okay. 4f and 5f orbitals are partially filled. So they are F block elements. Okay. Rendering them special properties. Now, noble gas elements are group number 18 of the modern periodic table and considered as the noble gas. The electronic configuration of the first element is helium in this group, which has an electronic configuration, outer electronic configuration as 1s2. Rest all the elements, neon, argon, krypton, xenon, and radon, all these are the inert gases. They have their outermost electronic shell configuration will be NH2 NP6. As the octet of these elements is complete and hence they are highly stable elements. They are non-reactive elements. That's why they are known as inert gases. Okay. So let me stop here. I'll continue with the details of these type of classifications with representative elements, then inner transition elements, inner transition and noble gas elements in my next video. So till then, if you have any doubts, please do write in the comment box, and you can also refer to my email ID, that is kasturi74@gmail.com. That is KASTURI 74@gmail.com. Okay, or if you can write in the comment box also. Okay, and if you're liking the videos, press the like button, share with your friends so that they can also be benefited from these videos. And if you have not subscribed yet, please do subscribe and ring the notification bell so that as soon as a new video is uploaded, you will be notified soon. Okay, and please don't forget to meditate before you start your day. Okay, so thank you for joining and have a good day.